Hi everyone, in this article we're going to talk about stage injection, what it is, why it is it, how to set it up. Now, stage injection is where you have more than one fuel injector per combustion chamber, whether it's a piston, cylinder or a rotary engine. The reason why you do this is that the fuel demands of the engine are such that it requires a large fuel injector or a fuel injector with a high flow rate, but such a fuel injector would not give accurate enough control over the fuel delivery under the low load conditions. So therefore the way that it's done is you have two or more injectors per cylinder or rotor. Often the primary one can be smaller than the secondary ones under low fuel delivery conditions and gives you enough delivery capacity for the high power conditions. I've only seen these from factory on a few engines, so the Mazda rotaries is an obvious example. You could maybe include some motorbike engines which have secondary injectors up above the throttle bodies that they switch over to, although often that's for better vaporization rather than to increase the injector capacity. And the other one, of course, is the FA20 engine in the Toyota 86 BRZ FRS, where they have port injectors and direct injectors. Now, the first thing to understanding how the modular ECU handles stage injection is first of all to remember that the ECU has a complete fuel model built in. So that means that it calculates the amount of fuel that needs to be delivered to the cylinder or rotor, and then it works out what pulse width is needed from the injector based on the current fuel pressure and battery voltage to deliver that quantity of fuel. So what the ECU needs to do is to be able to work out how much fuel to inject on the primary injectors and how much fuel to inject on the secondary injectors and what pulse widths they correspond to. Let's pick a two-stage injection engine as an example. So the ECU calculates the quantity of fuel as per any other engine, and then it has to work out how much fuel to inject on the primary injectors and how much to do on the secondaries. It does this using the two-stage injection map. This value is a percentage which corresponds to the percentage of fuel that will be delivered by the secondary injectors. So if this is 0, that means that the ECU will attempt to deliver all the fuel using the first injection stage, or the primary injectors. If you put a value of 50% in the table, then it means it will try to deliver half the fuel using the primary injectors and half the fuel using the secondary injectors. Now note that this does not mean that the primary and secondary injectors will have the same millisecond duration. They will if you have the same type of injector in both primary and secondary stages, but in the general case that won't be the same size injector, and therefore the millisecond values will be different even if the fuel quantity is the same. And if you put 100% in the secondary injection map, then that means that the ECU will attempt to deliver all the fuel using only the secondary injectors in that RPM and load position. So as well as a traditional stage injection engine like an RX-7 engine, this also allows you to do things like the motorbike engine where you have the secondary injectors further up above the throttle bodies. At higher RPM you can only run those secondary injectors and take the benefit of the fuel vaporization. So the way you do that is at low RPM you'd put 0 in the map so it runs off the injectors at the ports, and at high RPM you put 100 in the map so that it runs entirely off the further up injectors. Now you can probably appreciate that it would be possible using this system to ask the injector to do more than it physically can do. For example, if you put 0 in the table and the primary injector just doesn't have enough flow capacity to deliver the amount of fuel that you need to before the next injection pulse comes around. The way that this is handled by the ECU is that you select a minimum off time for each injection stage. Generally 2 milliseconds is a good amount. What this means is that it's the amount of time that the injector can close. Where it opens again, it's as though it's doing a brand new pulse from a closed position. If you start to reduce that off time to a very small value, then the injector doesn't actually close all the way, which means that the amount of fuel that gets delivered is higher than what you would calculate from that millisecond pulse value. Now obviously with all of our testing of injectors, we're trying to minimise the amount of time it takes to deliver all the pulses to measure the fuel quantity. So it's in our interest to minimise this off time. But with our testing we've found that 2 milliseconds is basically pretty much a standard value that will give you good results on pretty much any injector. Now that minimum off time actually gives you the maximum duty cycle depending on RPM and whether it's a 2-stroke or a 4-stroke engine. For example, on a rotary at 6,000 RPM, that's 100 revolutions per second, which means 10 milliseconds are available for each injector pulse. If you have a 2 millisecond off time, that means that you have an 8 millisecond on time, so the duty cycle is maximum 80% at 6,000 RPM. At higher RPM, the maximum duty cycle is going to be lower. Now, if after calculating the millisecond duration required to deliver the amount of fuel that's been requested by the stage injection map, the ECU discovers that there's not enough time to do it while maintaining that minimum off time, then the ECU instead goes to an automatic staging mode. So in that case, it will deliver all the fuel it can on the primary injector, subject to that minimum off time. So in other words, at 6,000 RPM, if with an off time of 2 milliseconds, the maximum primary duration will be 8 milliseconds. From there, it calculates what quantity of fuel that corresponds to, and then the remainder of the fuel that needs to be delivered is delivered by the secondary injectors, or third, fourth stage, depending on how many stages you've got enabled. So therefore, if you set the entire stage injection map to 0, then the ECU will try to do all the fuel it can on the primary injectors and then spill over to the secondaries or later stages if need be. So in all our base maps, we set that stage map to 0, and that means that the ECU will automatically calculate the split between the primary and secondary injectors. As a tuner, you don't need to do anything regarding the staging then, it just all works magically. The only reason that I can see to change this is, for example, on a naturally aspirated engine where you get some cooling benefit from the injectors further away from the ports carrying more of the fuel than the port injectors, or it promotes better mixing or something like that, then that will be a reason to mess with that map and try to take some of the fuel away from the primary injectors and towards the secondary injectors. But otherwise, for 98% of installations, you can leave that map at 0. The modular ECUs currently support up to 4 injector stages. So a 3 or a 4 stage injection model is the same as the 2 stage, just with the additional stages on the end. So on a 4-stage injection configuration, you'd have 3 stage injection maps then. So one for the 2nd stage, one for the 3rd stage, one for the 4th stage, for the different percentages for each of those stages. And 100% minus the total of those ones gives you the amount of fuel that will be left on the primary injectors. Again, if you leave all those maps at 0, then you have the default behaviour, which is the ECU tries to do all it can with the 1st stage. If that's not enough, it'll spill over to the 2nd stage. If that's not enough, it'll go to the 3rd stage. If that's still not enough, then the 4th stage. Now, so that the ECU can correlate the fuel quantity with the duration of the injector pulse, the ECU needs to know the fuel flow rate as a function of the fuel pressure, and also the offset as a function of the fuel pressure and battery voltage. So because these may be different for different injection stages, each different injection stage has its own table in the ECU, which has to be set up, or you can select from a pre-configured injector model. The next point that we'll discuss is the output mapping. So the way that it works is that all the primary injectors are first, and then all the secondaries, and all the 3rd and all the 4th stage. For example, on a 2-rotor engine, injector output 1 is primary 1, injector output 2 is primary 2, then the secondary stage, injector output 3 is secondary 1, injector output 4 is secondary 2. If you've got a 3rd stage of injection, then output number 5 will be the 3rd stage for the front rotor, and output number 6 will be the 3rd stage for the rear rotor. And if you've got a 4th stage, then output number 7 will be the 4th stage for the front rotor, and output number 8 will be the 4th stage for the rear rotor. So we chose to do it that way rather than doing all cylinder 1 first, then all cylinder 2 and so on, because it's fairly common for people to have an engine wired up and then want to add another couple of injectors, thereby adding another stage. So that way you can do that and you don't need to change all the pins around that you've already done. And of course, on the plug and play ECUs, you can see which pins on the factory connector the other injector outputs come to. So for example, injectors 5, 6, 7 and 8 are all available on the RX7 plugins, so you can run a 3 or 4 stage injection system using the factory ECU connector. Thank you very much.